It is a snowy Sunday morning. It's so pretty outside. But anyway, so this is your work for February 10th, which is your asynchronous day. Make sure that you have done your Chapter 5 test before doing any of this. Remember to set aside 90 minutes for your Chapter 5 test if you have not done so. So today we're going to just do a review of Z-scores. You're going to need to know how and remember how to use a Z-score chart. And I'm not sure what the regular stat teachers did last semester with it being COVID, but I'm also going to show you an application on your graphing calculator. So here are the things that you need to do this lesson. The first thing that you need is a Z chart or a normal distribution chart. The normal distribution charts are right here. If you open the tables and charts and you go to normal distribution chart and either print that out or open that up, I would strongly suggest printing that out because it's, flipping back and forth between the chart. I'm going to use that. Also, you need either to print out inside the asynchronous classwork today this PDF, which I'm going to go over through and do with you, which is just a review of empirical rule, Z-scores, looking up Z-scores, and also the graphing calculator function, which I'm not sure if you have seen before. So that's what you need to have ready, either notebook, graphing calculator, and a Z-score chart if you have one from last semester. It's the same Z-score chart in regular stat. We use the AP version of the charts just so that you're not changing charts in between. Okay, so I'm going to open this up right now. And so I have that. Here's my normal distribution chart ready to go. And here is my worksheet that I'm going to do today, and also a graphing calculator. So it's Super Bowl Sunday, so these are my recipes. I didn't want to shut those down because I was just searching for recipes for today. So anyway, so here we go. Okay, here we go. So a study of elite runners found a mean body weight of 63.1 kilograms with a standard deviation of 4.8. Okay, so assuming that it's normal, anytime you see the word normal in this class, you are going to be using a Z-score anytime. So always look for that word normal, and then you'll be using a Z-score. Make a sketch of the weight distribution. Okay, so here we go. And then we're going to use our 68, 95, 99.7 rule. That's your empirical rule. So we're going to draw a normal curve. Hey, I'm getting better with the pen. Well, not that great. And then the mean is at 63.1. And then we have a standard deviation of 4.8. The empirical rule says to go down 3 and up 3, and you have certain percents in between there. So this would be 63.8 minus 4.8 minus. So if I keep subtracting 4.8 off, I get 58.3, 53.5, and 48.7. I am just adding and subtracting the standard deviations, 3 up and 3 down, and drawing my curve. Okay, and then it says using this rule. So if you're talking about the empirical rule, these are approximates. So approximately 68% was in the first standard deviation, 1 up and 1 down. So when you're talking about what a Z-score is, it's just how many standard deviations you are. So at the mean, you have 0 Z's. This is 1Z, 2Z, 3Z, negative 1Z, negative 2Z, negative 3Z. So standard deviation is just really a Z-score. It's how many you're adding up and down. Why do we have decimals? Because somebody can be in between these two numbers, between the 1 and the 2. That's really all a Z-score is. People make it more difficult, but it's really just telling you how far up or down you are on the curve. All right, so if that's 68, this is 34, then 2 standard deviations is 95%. And then 3 standard deviations, remember, is the 99.7%. Okay, so if we go through and we do these individually, if this is 95, then from here to here is 47.5. And if we subtract it from there, that is 13.5 on each piece. And then 99.7 would give me 2.35. And then this little piece outside here is 0.15 on each tail. 2.35. Okay, so here we go. So the question is, find the proportion of runners whose body weight is between 48.7, that, and 67.9. So we just go through and we add them up. So 34 plus 34 plus 13.5 plus 2.35, and you add them up and you get 83.85. So I just went through, divvied up the 68, divvied up the 95, divvied up the 97, and then you add your pieces together. That's the empirical rule. The empirical rule is used as an approximate percentage, but Z-scores, that Z-score chart is your actual percentage. It's like dead on. For example, if you look at 1 on a Z-score chart, up 1 and down 1, this is not just 68. I think it's like 68.2 or something like that. So these are off. 2 standard deviations on the Z-score chart isn't 95. It's really like 92.28 or something like that. So these are approximations. Okay, it says what proportion of the runners have body weights below 60? Okay, so 60 is somewhere in between here. So we're going to use a Z-score. So remember, a Z-score is your value minus the mean over the standard deviation. So our value always comes first. That tells me whether I'm above or below the mean. This, I'm going to get a negative because I'm below the mean. So 60 minus 63.1 over 4.8. Do the math, you get negative 0.65. Okay, now there are 2 ways to calculate this. The first way is just using your Z-score chart. So if I go to my Z-score chart and I look up negative 0.65, let me scroll down, and I do negative 0.6 and then 5, I will get right here, let's see, that is, oops, negative 0.65. Remember, this is your tenths, this is your hundreds. You scroll down, and you get 2,578. So we're on the negative side. That tells me this area right here. That's this shaded area, if you remember from that. So if I want less than, I am at a mean of 63.1, and I want 60 and below. That is the shaded area I want. It matches up with the chart, and that answer was 2,578. Go back to it. Let me show you again. So this is the area that's shaded. These are the areas that are given in here. And I go to negative 0.6 and then 5, and then that's where I get my area. And I don't have to do anything with it because that is the area that I want. All right, so the answer to that then is approximately 25.78 or 26%. Okay, now I'm going to show you how to use a function on your graphing calculator that replaces your chart. So you're going to go to second vars, and you're going to go to number 2, this NormalCDF function. When you go into the NormalCDF function, it says, what's the lower bound, upper bound, the mean, and standard deviation? Okay, so the mean and standard deviation is always 0 if you're in a Z and 1 for the standard deviation. Remember, a Z of 0 is the mean, and standard deviations are 1 up and 1 and adding up 1 and adding down 1. So we need to talk about what this lower and upper bound means. This symbol right here is negative infinity. You don't need to put, that's a negative 1 with 99 zeros. Okay, we're in Z-scores, so we don't really need to use that negative 1E99. So if we're talking about a Z-score, okay, I'm going to go right here. I'm going to draw this one again. We want 60. So we want from negative infinity out here to 60. So my lower bound, your left to right, that's lower and upper. It's always going to be left to right. Your lower bound is infinity. On a Z-score, Z-scores go -3, and then this would be -4, and this would be -5, and then this would be -6. I use for infinity just like -8 or -10. You could even use -6 and it would be fine. Okay, that could be used for negative infinity. So we have negative infinity to 60. So I'm going to go into the calculator and I'm going to leave that as I can tell it -8. It's just what I use. I don't know. You can use -10. The upper bound on that one, the upper bound is a Z-score. Sorry, we want to use it as a Z-score. The upper bound of 60 as a Z was -0.65. So we want to transfer it to a Z. So you still have to show that work. So you still have to do the -6.5 first. Okay, so -8 to -0.65, and then keep your 0 for the Z mean and standard deviation. And then we just hit enter, and it automatically gives you this. Now, if you have an older version of the calculator, this is what you're going to have to type in. You're going to type in -8, comma is above the 7, then your Z, and then your 0 for your mean and your 1 for your standard deviation. When I hit enter, there's the area for the chart. So this function replaces you looking up a number off of this chart. So it replaces the Z-score chart, this function. All right, so let's write down where I went. I went to second vars, and let's write that down. Okay, so we're going to, let me change my color here. Okay, so to do this one, I'm going to do, let me use red. So you have this written down. Oh no, we already used red. Oh, let's see, green. Okay, so you're going to go to second vars, and you're going to go to NormalCDF. And you do lower bound, because this is, we wanted lower bound, less than. So I'm going to put in a -8 for infinity, and then the Z-score at 60. The Z-score at 60 was -0.65, and then the mean, and then the standard deviation. So it's always lower, upper, and then 0, and then 1 for any problem you're doing. So you're going to do the NormalCDF function on your calculator. So go to second vars, NormalCDF, lower, upper, 0, 1. All right, let's do another one, and I'll do it both ways. All right, it says, what proportion of runners have body weights above 70? So R value minus the mean over the standard deviation. That's an 8, sorry about that. And we get a 1.44. Okay, so let's graph it, draw a little curve. We have 63.1, and we want above 70. All right, so we want this area. All right, let's do the function on the calculator first. So we're going to go to second vars, and you're going to go to NormalCDF, and you want lower. This is your lower bound, and then your upper bound is infinity. So I'm going to type in the Z-score for 70, 1.44, infinity is 8, and then 0, and then 1. That's what I'm going to use on the calculator. So if you have an older version of the calculator, you're going to type this, and then the comma is above the 7. I'll show you how to do it in a minute. Let me do it on the chart first. So I got a Z of 1.44. So I'm going to go over to 1.4 and then down to 4, and that gives me 9251. That, oops, sorry about that, I clicked something. That is this area. I don't want that area. I want this area. So I'm going to do 1 minus that to get my answer. All right, now, if I do, so when I look up this on the chart, I get 9251. That's the white. I need to do 1 minus. If we go to the graphing calculator and go second vars, we go to NormalCDF, you can type in the lower bound, which was 1.44, and then comma if you have the older version. The upper bound is 8, which is infinity, or you can type in like 8,000, it doesn't matter, 8,000, whatever you want to use infinity for, and then 0 and 1, and hit paste. All right, and that automatically gives me my answer of 7.49%. So the graphing calculator saves you from doing the subtraction, and it replaces the chart. All right, so back to The answer is going to be 7.49%, I think. It was around 7.5%. All right, now let's talk about a backwards one. We're going to calculate and interpret the 45th percentile. All right, so now these are what I call backwards. So we have a mean. When we want to know of 63.1, we want to know where 45%, this boundary of where 45% of the runners lie. Like if you hit here, then this is, you are in the bottom 45% for weight. All right, so always when you're given the percent, do it to 4 decimal places if you're using the chart. So this is the area, that is not the Z. So we have to, using our Z-score formula, we're going to find this value. We're going backwards. Value minus the mean over the standard deviation. Now we need to find a Z. Biggest mistake is people take this area and put it right in. You've got to find the Z. So 45% is on the negative side. So I'm going to go over to, let me clear some of my annotations. Okay, so cleared up a little bit. Okay, so I'm going to find the closest thing to 45% in here. All right, so I'm going to go down. Closest thing to 45%. Remember, it starts at 0 and goes to 50 here, so half of it on the negative side. And then it starts at half and goes to 100% because this is this area. So if you're at the mean, you're at 50%, and then it's going to increase. All right, so I'm over here on the negative side. And I want 45%. 45, closest thing to 45 is somewhere around here. Okay, and that's 0, 1, 2, 3. So let's see which one's closer. So this is 17 away, and this is 22 away from 4,500. So we're going to go with the closest. We're going to go with 17 away. So I'm going to use negative 0.1 and then 3. If I go up, that's a 3 up there. So the Z-score is negative 0.13. And then just use a little algebra 1. Multiply both sides by 4.8. 4.8. And then add 63. And then you should get 62.47 for your X. So multiply by 4.8, add 3.1, and you get your X of 62.47 kilograms. Okay, let me show you now a calculator function, and it is called inverse norm. Not all of you have this. Not all of you have this, just the 84s. That's why I tell you guys to get the 84s. Anyway, here we go. So let's go to the 84. You're going to go to second bars again. Clear my home screen. Second bars. And you're going to go down to number 3, inverse norm. Okay, inverse norm is area. That's always area to the left. All right. Oh, this is the newest version. Some of you don't have this. So always do area to the left. The newer version of the calculator asks you left, center, or right. It's kind of nice, but just use, most of you probably don't have this. I have the latest version. So this is always going to be area to the left. 0 and then 1. Keep it. That's your mean and standard deviation. Okay, so if I look at my problem, the area to the left is 4,500. So all I have to do is type in 0.45, and then the 0 and 1 is there. If you do have this, keep it to the left because that's the area to the left, and then hit paste. And then most of you don't have to put this in. So if you have the older version and you just have a blinking after inverse norm, you always do area to the left, 0, 1. Enter. There is your Z-score. See the negative 0.13. There is your Z-score for the problem. So you get that off of the calculator, and then you solve your problem. So inverse norm. So you're still going to second bars, and you're going to put in the area to the left of wherever that bar is, that X you're trying to find. Area to the left, and then 0 and 1, and it will give you your Z-score to put in. Once you have your Z-score, you still have to do a little algebra to solve it. All right, next one. Find the proportion of observations that satisfies these two z's. Sketch the normal curve and answer the question. All right, so we want to know the area between negative 1.51 and 0.84. All right, so using the z-score chart, if we use the z-score chart, we will go to negative 5.1, 1.51, excuse me. So negative 1.5, arrow down to 1, and you get 0.655 or 0.655. So that area is right here. So that is that. Let me change my color here. So that is that area. And then we're going to look up 0.84. So go back to the normal distribution chart on the positive side and do 0.84. You get 7,995. Okay. That area is, and if I shade all that, that is all the way down. Anytime you're doing what we call between twos, so between two z's, you always subtract the areas. Okay, so between two z's, you always subtract the areas. You want to take and subtract this little piece off of there, so we're end up with just that area. So we take this minus this, and you'll get your area. On the graphing calculator, we're going to go to second vars. Super easy on the graphing calculator. You're going to go to NormalCDF, and the lower bound, negative 1.51. The upper bound, 0.8401, and it does it straight automatically for you. So if I go to my graphing calculator and I go to second vars, NormalCDF, and I just type in the z's. So negative 1.51, comma, if you have the older version, negative 0.84, leave it as the 0 and the 1. If you have the older version, yours looks like this. And then hit enter. And there is your area straight away. You don't have to do any subtraction at all. So I get 1349. Okay, so when I do that, I get 13.49%. That's not right. I did something wrong. Did I type something wrong? Oh, it's positive 0.84. I knew I did something wrong. Sorry. Let me redo. Second vars. I put a negative in there. Negative 1.51 to positive 0.84. Or nobody's perfect. Okay, but I did catch my mistake. Negative 1.51 to 0.84. And then there you go. Sorry about that. Okay, 0.734. All right, so you get 0.734. Oops. I wrote it right and put a negative in there. So the answer to this problem is about 73.4%. How did I catch my mistake? 80 minus 6% is around 74%. So that's how I got my mistake. All right, so let's look at a backwards one with this. Okay, so back to what is a z-score on a normal distribution? That 33% of the scores are above it, So that means we're on the positive side because this piece is 0.33, is 33%. So we have to be on the positive side if 33% are above the z. So two ways to do it. If this is 33%, then 33 minus 100 would give me what down here? So I could look up on the positive side because you have to look up this area on the positive side. So if you're using the chart and you're going to go to the positive side, you got to look up that area. So that's going to be 67. Or it's much easier if you use the inverse norm, you can just do 67. So 1 minus 33 is 67%. So I can either use inverse norm if you have that on your calculator. And we're going to do area to the left, 0.67, and then 0, and then 1. Or we're going to look up 0.67 or 6,700 in the positive side. Let me do the normal distribution first. We're going to look up the closest thing to 0.67. This is dead on right there. There we go. 0.44. Sometimes the chart is easier. So 0.44 is 6,700. So there's my Z. 0.44. Or I will show you how to do it on the calculator. You're going to do second bars and then inverse norm. Area to the left is 0.6701. And like I said, I'm just going to keep it area to the left because of the new version. I have the newest version of the calculator and hit paste. And then there you go. 0.44 is your Z. If you have the version I have, then you could also do it like this. This is for people that only have this version with this choice. I wanted 33% to the right of the Z, so I could do this. Do you see that? And that's the area to the right. This is only the newest versions of the calculator allow this. So it's the same answer. So 67% to the left is the same thing as 33% to the right. And if you don't like these calculator functions, then just use your good old Z-score. All right. So the answer to that was a Z of 0.44 positive because we're on the positive side. All right, here we go. A normal probability plot for the amount of lactic acid in a sample of 30 pieces of cheese is shown below. Is it normal? Okay, so this is a new chart. Basically, what it does is it takes a set of data and it calculates, these are all the X values. This is the data set. So this data set goes in between like 0.8 to about 2.1 something. So you don't have the data set, but these are all the little data sets graphed. And it just makes a scatter plot. And what it does for each one, so like this point right here is about 0.8, which is the actual X value, the raw value. And then it takes the mean of the data set, calculates the mean, and calculates the standard deviation of the data set. And then after it does that, it calculates a Z-score for each one. So if this Z is close to 0, that means the mean is close to 0.8. So this Z looks like it's about, I don't know, like that's 2. A little less than 1. Let's just say it's about 0.4. I'm making that up. So this is that ordered pair there. So let's look at 1. The mean is not 0.8. Sorry. The mean would be around here. Sorry about that. The mean would be here at 0. That's -2. It's -2. So it would be a -0.4 Z. All right. So what would be approximately the mean of this data set? The mean of this data set would be approximately right here at 1.5-ish. So the mean, how do I know it's the mean there? Because a 0 of 0 is a mean. So this ordered pair is about 0.8 and about -0.4, -2.4. Oh my gosh, I'm sorry, guys. It would be -2.4 about. So if I were to draw a graph, a normal curve on this, we're looking like a mean of 0 would be about 1.5, maybe 1.5, about 1.5. Let's go with 1.5, maybe 1.52. That would be the mean. And then your lowest number down here is about 0.8, and your highest number here is about more than 2.1. So let's say 2.13 or so, I'm guessing on that. Okay, so that's the low to high. This Z-score, if you see it, is above 2. So you're out in the tail. This Z-score is below -2, so you're in that tail. And 0 is around the mean. All right, so you're going to get, for this number, each ordered pair is the raw data and then the Z-score. The raw data and then the Z-score. Okay, so why is this important for you? All right, let me clear this out. All you have to know that this is called a normal probability plot. Oh, this is called a normal probability plot, or it's also called a normal quantile plot. Your calculator will do it for you in a set of data. We'll talk about that later in the semester, but it is in your stat plots, and we'll show you later. Okay, so a normal quantile plot. All you need to know that is if it is a normal curve, if this data is a normal curve, it will go up in a linear fashion. That's it. So if you see this and they ask you to comment on it, all you have to say is that, yes, this is, never say normal, say it's approximately normal. That's a big word in here. Never say exactly normal. Nothing is exactly normal. In real life, you say approximately normal because it has a line, the positive slope, and it's in a linear pattern. That's good enough. You want it to look like this when you sketch it. If it looks like this when you sketch it, that is not linear. That's all you need to know about these normal probability plots. The calculator does them for you. I've never seen you have to do one. I just wanted you to understand where those ordered pairs are coming from. It's also called a normal quantile plot, depending on which day they want to talk about it. So that is a normal probability plot. All right, so I want you to pause the video and try these. And then I'm going to kind of quickly go through the second worksheet. See if you can do them. I don't care if you learn the graphing calculator function or not. It doesn't matter to me. So you can either use a normal chart or the graphing calculator, whichever you feel more comfortable with. So at this point, pause the video. Do the 2B one. It's exactly like the same thing. And then restart it and make sure that your answers are correct. Okay, I'm just putting my 544 in, adding 3 up, subtracting 3 down. These should not be negative, but I'm not going to get into that. So let me redo this line. It's just a sketch anyway. Okay, so we have 235, 38, 1, 645, 750, and 853. All right, here we go. We want between 338 and 853. It's 647. That's not a 5. Sorry about that. That's 7. Alrighty, so we just went between 338 and 853. So if you're using the empirical rule, there's 68. 95 would be 45.7 here, 45.7 here, 2.35 here, 2.35 here. That gives me 99.7. And then these tails are 0.15 each. Those tails are 1.15 each. So all you have to do is add from 338 to 853, and you should get 97.35. You could also use that normal CDF function. Watch how I can do this. I can go to my calculator, and in the normal CDF, the lower bound is 338. You can use raw data too. Upper bound, 853. And then for the mean in raw values was 544, and the mean for raw values was 103. If you do that, lower, upper, the mean, and then the standard deviation. You can use raw values or Z-scores. When we're doing Z-scores, the mean is 0 and the standard deviation is 1. All right, next one. What percent of the Z-scores are below 500? So we have 500, make a little tail area. So we want a z, so we do value minus the mean over the standard deviation. We get a z-score of negative 0.43. Oh. And then you can either use your z-score chart and look that value up and it gives you exactly that area, or using the calculator, you can go to NormalCDF again and do lower. Oh, lower is -8 because you're at infinity. Upper is negative 0.43, and then 0 and 1. Sorry, I'm trying to rush here. So lower negative infinity down here. Upper would be the z-score at negative 0.43. And then the mean is 0 and 1 because you're using z-scores. All right, next one, above 800. So above 800, you have 544 for GREs, 800 here. And you want to find this tail area, so you calculate your z. When you calculate the z, you get 2.49, NormalCDF. So you have a lower bound, 2.49, upper bound, infinity. Remember, I just used 8 or 10 or 800, whatever you want to use, 0, 1. If you're doing the calculator, if you want to use your chart, you're going to look up 2.49. So you're going to go to 2.49 all the way over to here, 9936. That gives you this area, 9936. But you want this, so you're going to have to do 1 minus. If you use your NormalCDF on the calculator, it will give it to you quickly. You will get 0.64%. All right, now a backwards one. 34th percentile. The mean is 544. 34%. So you can either look up the closest thing. You're on the negative side. The closest thing to 34% on the normal curve. So you go to 34%. And we are around here. Looks like the closest, negative 0.41. So that's my z. I looked up the closest thing to 3,400, negative 0.41. If you have inverse norm, so you can use inverse norm, and you're going to type in area to the left, 0, 1, and it's also going to give you negative 0.41, either way. Now, once you have that, that is your z, x minus 544 over 103, and you should get a value of 501.52, so approximately 502. GREs, or like SATs, they don't come in decimals. So GRE is a graduate exam to get into grad school. Okay, almost done. Find the proportion of observations that satisfies this. So we can go, it's a between two. Oh, we're on the positive side. Between twos are all the same, so you're between 0.51 here and 2.84 here. So we want this area between these two. So this is 0.51, this is 2.84. So two choices, you can go to your normal curve and look up 0.51. 0.51 is 6950. and then 1.84. So you can look up 6950. So this area would be here of 6950, and then go to your Z-score and look up 2.84, 99.7, okay, and that would be this area. Subtract out the green. I'm going to take that green out, so you're going to subtract these two, and you will get your answer. Or you can just go to NormalCDF on the calculator, which everybody has. Once you get used to the calculator one, it's easy. So your lower bound is, was it negative 1.51? It was, wasn't it? Oh, shoot. I have two different problems. That's crazy. On my paper that I printed out, it says negative 1.51, and on here it says positive 0.51. Okay, that's nuts. Sorry. Let me make sure. Oh, that was for the A. All right, so I did do it right. Okay, so positive 0.51. Let me go back to my calculator. So positive 0.51, and then we're going to go positive 0.51 to 2.84. Sorry, there was a typo on my paper I printed out. So lower, upper, 0, 1. Okay, and you get 0.3027. You can also get that from doing 9970, which was 2.84, minus 0.51, which is 6950. And you approximately get the same amount. So this was 0.2. Right, so it's a little off when you use the chart and when you use the calculator, but AP will accept either answer, and if it's a multiple choice question, it will be close enough that you can pick. The calculator is doing a calc integral between these two, so it is taking everything to like 10 decimal places and doing a calc integral, so a little more accurate. Okay, the last two, here we go. All right, so what is Z-score in a normal distribution? Has 22 scores above it. So this is 0. We want 22% above it. So 22% above it is 78% below it. So you can go to your Z-score chart and look for the closest thing of 78%. And the closest thing to 78% or 7,800 is right here. That is 6 away. So the Z-score is actually 7, 7. So the Z-score on this one is actually just 0.77. If you have inverse norm, you could do the area to the left is 78, 0, 1. If you have the newest version, you can even do the area to the right and type in the 22 if you have the newest version of the calculator. Either way, you get a Z-score of 0.77 positive. Don't confuse that. This is an area. This is 0.778, 0, 0. These are areas. Okay, so be careful with that. So that's a backwards. And then last one, it says, is this normal probability plot? Is this approximately normal? And the answer to this is no, because if you trace it, you can see a curvature. And that's all you need to know, is that you see a curvature in this line. So this is not approximately normal. The mean, though, is going to be still at the 0. So the mean is approximately around 21-ish if you were asked. So this is not normal. This is not normal. Actually, this would look like this. You have a large percent right here. There would be like So this is called a right skew or a positive skew because where the tail is going. Okay, so there's your review of Z-scores. You can continue using your normal distribution chart, or you can learn the new calculator functions I showed you if your Prom and Stat teacher didn't show you that last semester. So this is the video for the async on February 10th. So all you have to do is today, the chapter 5 test is due by midnight. Make sure you allot 90 minutes for that. And then watch this video. You don't have to upload it, but I expect you to know basic Z-scores now. And if you have any questions on this, I will have tutoring on Thursday from, what time is tutoring on Thursdays? 1:30 to 2 on Thursday on a Google Meet if you have questions on this. Sorry, I made so many mistakes on it, but I'm not going to go back and edit because it already takes too much time. So anyway, so have a great day. And if you have any questions on this, then you can ask during tutoring on Thursday from 1:30 to 2. Make sure you get your syllabus sign-off thing done by Thursday midnight. I am not accepting the syllabus sign-off after Thursday midnight. It is right here. If you go to the home page, make sure that you go into read your syllabus and get that checked off. I'm not accepting it after Thursday at midnight. Okay, have a great day, everyone.